Hi everyone and welcome. This is Nafis Ansari and today I'm going to walk you through an end-to-end data engineering live streaming project I've recently built for a rides booking scenario. So in this project I have utilized Uber's open dataset for demonstration purposes. Okay, so the goal of this project was to design a robust real-time data ecosystem entirely within Azure. I built out the architecture to handle both historical batch data as well as the live streaming data, and all the data is governed and orchestrated seamlessly within the Azure architecture. Okay, basically within the Azure environment. So this is our architecture. Okay, so in this, for the historical data, I have built a parameterized Azure Data Factory pipeline to pull the bulk data set sitting in our GitHub repository, and using that pipeline I pull the data and land it securely into the Azure Data Lake storage Gen 2. Okay, and this is the very basic web app that I have built. So all of this data is then ingested and processed using Azure Databricks to ensure data governance. The entire environment is secured using Databricks Access Connector and Unity Catalog for role-based access control. So let me just quickly show you the repo. Okay, so basically this is my Uber data engineering project repository, wherein I have the historical data and all the mapping files. So these are the mapping files that I will be using to ingest into my bronze layer within Azure Data Lake. Okay, and this is my bulk writes. This is nothing but the historical data that every organization has stored in their databases or in their premises. Okay, and yeah, so this is the historical batch data that I was talking about, and this just hold on, this is the basic web app and all the Python files and scripts that I've built to accommodate that web app. Okay, so let me quickly just ignore all the tabs and everything. Let me just quickly move myself. Okay, so let me run this script quickly. Okay, and hold on, scripting is disabled on this system. Let me just quickly set the policies, and yeah, we're good to go. Now I'll just open the web app that I was talking about. Okay, so yeah, so this is the web app I'm talking about. What we will be doing is, this is very basic web app, nothing fancy, just to simulate that how exactly an enterprise works. Okay, so we are going to book rides like this. Just click on this book a ride button, and yeah, it's confirmed. Okay, so that's it. This is it. Okay, this is what the web app does. Okay, and yeah, so this is my Azure portal, wherein I have created my Uber project resource group, and I have already created and tested all the resources within the resource group. Okay, so going back to my architecture. Yeah, so yeah, in this architecture, so basically we are creating a Medallion architecture. Okay, so inside Databricks, the data flows through a classic Medallion architecture. Okay, the raw stream lands directly into the bronze layer, which is this. In silver layer, the real magic happens. Okay, so I perform complex transformations, joining the live streaming data with our historical bulk data that resides in our GitHub repo. Okay, and all the mapping files as well. So what we do is we join the live streaming data and the historical data that is residing in a GitHub repo. For joining that data, we use Jinja templates, which is nothing, just a templating tool that we use within Python. Okay, so this basically joining creates our one big table, which is nothing but the silver layer. Okay, and within gold layer, we use Spark declarative pipelines to basically serve the business ready analytics. Okay, I mean, just serve the data to our BI teams and different departments within our data team. So yeah, simple overview is we pull data from GitHub using ADF, and we publish our events or rights booking via this web app to our events hub. Then we pull both of these data streams, I mean the batch data as well as the live stream data, into our Databricks. In the silver layer we use templating and joining the tables, okay, all the tables, and we create one big table, and then we serve this data into the gold layer. Okay, so this is basically the overview of this project. Okay, now so what I'll do is I'll basically show you the initial ingest and pipeline run demonstrating a full data refresh from our sources. Then I'll trigger a live driver update to demonstrate how the pipeline handles slowly changing dimensions as well. I mean, we will be demonstrating slowly changing dimension type 2, and finally we'll run the pipeline again to see the state, I mean the changes that actually has happened after implementing slowly changing dimension type 2. Okay, so just, yeah, so going back to our rides booking app, we book a ride. Okay, first we go to my Azure Data Factory, Launch Studio, yeah. So this is my ADF pipeline, which basically pulls the data from GitHub using HTTPS dataset. Okay, and yeah, we ingest this data into our Azure Data Lake storage. Okay, which is this. Yeah, so in the Azure Data Lake storage, inside containers, we have a folder called raw, wherein in the ingestion folder the data will be ingested via Azure Data Factory. Okay, and let me go to, yeah, so this is my Uber project repo, wherein I have the bulk data set for the rides booking. This is a massive data set. Okay, and we have all the mapping files that we will be joining going ahead with the live streaming data that we are going to generate right now. So is it, yeah, so this is our Azure event hub, so which is named Uber Stream Interface. These are naming conventions I used because for simplicity. Okay, and these names are supposed to be unique, so that's why I'm using this name. So yeah, this is my Uber's stream event hub, basically Azure event hub. So whatever bookings I'm making via this API, where is it, this web app API, it is going to be fetched by this event hub. So let me quickly show you the events that are already stored. Data Explorer, all, yeah, inside Data Explorer, here we can see whatever bookings that we are making right now. So I've already made a couple of bookings earlier for testing and all, so these are the rides that are being booked. Okay, so let me just, is there an option to sort this thing with the latest events that we receive? Okay, never mind. So let's say this 111th event is the one. So the right now that it's 11:18 p.m. Okay, 8th April 2026, 11 p.m. So what I'll do is I'll, in front of you, I'll make a few rides bookings, ride bookings. Okay, one. Just hold on. Let me make a couple of ride bookings and we'll be right back. Yeah. So I've made a couple of more ride bookings. So let's see, are they captured by this event hub? Yes, perfect. See, earlier we had 111 events, and right now we have 9 more events. So basically 120 events right now. These were all made right now. See, yeah, these. Okay, so how this is happening? Okay, so what I have done is, so basically this is the script that is actually ingesting the events, pushing the events to the event hub. Okay, so I'll be uploading all the code files and all the scripts and everything to my GitHub repo. I'm currently working on organizing it. Okay, so I'll share the link as well at the end of this demonstration. So yeah, basically, so this is how a real-time web app develops events, and those are captured by the event hubs. Okay, so here the events are being captured by the Azure Event Hub, and since we have these number of events right now, let's proceed with the pipelines and everything. Okay, what I'll do is I'll quickly go ahead and just clear the screen, full screen. Yeah, I'll run this Azure Data Factory pipeline. Okay, so the pipeline is running the Azure Data Factory. Let's see, success. So it has successfully ingested all the mapping files as well as the bulk load that I was talking about, and it has successfully ingested it to my Azure Data Lake. Okay, so let me just quickly refresh. Inside the raw container ingestion, see, here it is, and you can see the timeline. It's 8th of April 2026, 11:36 p.m. Okay, it just happened right now. So inside this we have all the mapping files, let's say map city and everything. So this has the city ID, state, city name, region, etc., and the updated ad. Okay, so we will be performing slowly changing dimension type 2 on this particular mapping file. I mean, we will be creating dimensions at the end in the gold layer, dimensions and fact tables for serving it to our BI or analytics team. Okay. So then there we can see what exactly happens with slowly changing dimensions type 2. Okay, so I don't want to save. Okay, yeah, no mind. Yeah, change some. It's fine. So these are all the, see, we have payment methods, like is it a card or not, is it credit card, debit card, etc., etc. All these files are there. Okay, now what I'll do is I'll go to my Databricks and launch the workspace. This is where actual data processing and all the heavy lifting will be done. Okay, so this is my Azure Databricks workspace, and inside workspace I've created the folder work project, and yeah, so basically this is where we run all our pipelines and everything, and process the data in Silverlake, as well as we do the Spark declarative pipeline in the gold layer. Okay, so let me just quickly start. So what I'll do is I have this notebook for data ingestion. Okay, so this is the initial data pull from Azure Data Lake. Okay, so in order to communicate with Azure Data Lake, we need an access connector and something like an access or ID. Okay, to actually access the data from our data lake. For that I have used Azure Databricks access connector. You must be aware of it. Okay, using that I am going to this is the script that I've used. What I'll do is I'll quickly run this. Let me just quickly move myself from the screen just to avoid the distractions. Okay, so what this notebook does is it basically pulls the data from our Azure Data Lake, which is nothing but this, from the raw container, it pulls the mapping files as well as the raw bulk ride, okay, the massive data set into our Azure Databricks. Let me, yeah, so this is done. Yeah, the other files are okay, so I'll just quickly query the bulk rights tables here. This is what I was talking about. These are the columns, and this is the bulk rights data, which is nothing but the historical data of the company. And these are the columns, and this is basically an integer or float type. Okay, this is a string, timestamp in string format. Then we have base fare, booking, timestamp, cancellation, reason, ID, contact number, everything. So this is basically the neat and clean structured historical data that was residing in our GitHub repo. And let me just quickly okay, so the important thing, okay, so this is basically the events that I have fetched from the event hub into my Databricks workspace. Okay, so what we need to do is, this is the bulk rights. We have more mapping files, 6 more mapping files, and this is the live stream data, okay, that I have pulled from the event hub. These are very unstructured in JSON string format. Okay, so we need to make transformers. See, this is not readable at all as of now. This is a key value pair structured data set, and basically a string, I mean JSON string format data right now. So we will be formatting, performing transformations to make it to look exactly like this bulk load data set. Where is it? Yeah, so you can see, right, all the columns are separated neatly and properly structured data, and this is a string. So we'll make sure that this data looks exactly like this. Okay, so this was pulled right now in real time. Okay, for demonstration, what I'll do is I'll quickly run this notebook again. So see, as you can see, we have 83 events right now. I mean, what happened is, in our over topic we have a retention policy, okay, that so and so data must be retained for that particular duration only. Let me see, where is it in properties? See, retention time in hours. So I have set it for 100 hours as of now. We can maximum say set it to 7 days. Okay, after 7 days, whatever data it is capturing, it will delete it automatically. It will be just gone. Okay, so it's up to the company policy how long they want to retain. For demonstration, I have set it to 100 hours. Okay, so that is why you see this 83 writes. Okay, if I hold on to this data, this into the event hub, this will be gone after 100 hours. I mean, as soon as it reaches. That is why you see, hold on, see, you see the sequence number starts from 29 and not from 0, because whatever data was before 29, it already exceeded that time retention period of 100 hours. So we have only 20, I mean the event starting from 29 to up till the latest one. So what I'll do is I'll quickly book more rides, and as you just saw, we have 83 rides over here. Okay, this is from the bronze over rides. This is the name of the table that I've created for the live stream. Okay, so let us quickly book at least 5 more rides. Hold on, I'll be right back. Previously we had 83. Okay, yeah, so done. So we should now see at least 127 events. Previously we had 120, now we should have 127. Yeah, 128. Okay, and the time you can see it's 11:59. It is happening in real time. And yeah, the data that I was saying, see, this is the JSON string format data set in key value pairs, basically a big dictionary, and we have to transform it into that structured data just like the bulk writes. Okay, so right now here we can see 83 only, right? So what I'll do is I'll quickly run the notebook and let's see. The bulk write data remains as it is because it is a historical data. Now no change has happened into it. We will be in the future making some changes to one of our mapping files, basically the cities map cities file, to demonstrate the slowly changing dimension type 2. Okay, because in future maybe let's say an admin comes and he adds a new city, okay, or just maybe the city name changes in future, so we have to keep it up to date, right? For that we use slowly changing dimension type 2. So this has run successfully, and here you can see this is the bulk writes, and yeah, this is the live stream data that we are getting from the event. Where is it? Hold on. Yeah, so the data that we pulled, apologies from my end, I made a small confusion over here. The script is basically for pulling the data stored in a data lake, not from the live stream. Okay, the live stream data will be basically pulled via this script. Where is it? Workspace. Yeah, we will be pulling it dynamically using the pipeline, the Uber writes in just pipeline that we have over here. Then we can see more than 83 writes. Okay, right now you saw 83. We once the pipeline runs successfully, we will be able to see all the updated writes bookings that we made. Okay, so into transformations we have these files. So, it is silver ingest. Okay, yeah, so this is the initial ingestion, wherein what this will do is this will fetch the data from Uber event hub. Okay, the event hub namespace and the topic in real time. It will dynamically pull it. We are using Kafka options over here. Okay, so basically event hubs are based on Kafka, so that's what we are doing. I'm not going very deep into the technology over here, just I'm showing you this is the connection string, and using this we are going to pull the events. See, this is the send policy that I've created, and we use this primary key connection over here to pull the data into our Databricks. So this way both the batching the batch data as well as the live stream data is pulled into our Azure Databricks workspace and into the pipeline. Okay, see, Kafka options, bootstrap servers. So basically over here the EH namespace is our event hubs namespace, which is nothing but Uber stream name interface, that is this, and the EH name, the event hub name, actual name. So namespace and name is different. Okay, namespace is the, we can say it's like a parent folder, and EH name is basically the actual event hub that we are using. So basically this is Uber topic, and we use the connection string to connect it, which is nothing but this and policy connection string, and this is the configuration. We are using Spark declarative tables over here. So yeah, so I'm not going very detailed into the coding part. This is it. Next we have the silver Python table, wherein what we are doing is, so we are importing the libraries, and this is the schema. Okay, so this schema was pulled via, from this. Where is it? Just duplicate this tab. Yeah, so this schema was pulled from this. Okay, this bulk writes data that we have, I pulled it from that, and yeah, so this is what the schema looks like for our table. And yeah, so we are creating empty streaming tables and we are doing the bulk initial load using append flow from the Spark declarative pipelines. Okay, so we are appending the folders like see the table staging rights. The target is staging rights that we created over here, which is nothing but the streaming table that we are going to further use in our pipeline, and name of that particular bulk load, I mean the rights bulk table is append bulk history. Okay, see, then we define this function and we use that function to read the stream from this staging rights. So this is basically the code, you can go through it. Then we have this, the most important part, the Ginger template. So what we are doing is basically this. So we import the Ginger template, and this is nothing but the metadata driven pipeline that we are building. Okay, so this is the metadata configuration. Here we have the dictionaries into which we, so basically this Ginger template is being used to generate the SQL join. Okay, this is in very simple terms, Ginger template over here is a code that will generate the code form. Okay, so what happens is whenever we say when we have a lot of mapping files and streaming files and what all other data, I mean, so to join that we have to create a lot of joins, left joins and all. So those are very those get very messy and complicated over time. So what we are doing is we are creating a configuration that will do the code work for us. Okay, and the SQL join thing for us. So Ginger template does that. Here we have the mapping configurations. What we are doing is so we are creating a staging column over here which says nothing but the cancellation reason. These are the mapping files that we had in our see, mapping files in our repository, the GitHub repository. Okay, so we have the configurations. I have created and tested it. Okay, so it took me a lot of trial and error, and finally this works. It is a bit complicated but very helpful in future, because let's say tomorrow our team comes to us and says, the manager says like, hey, so and so new data is being added to our I mean so and so is the mapping file, kindly add it to our pipeline. Okay, so at that time we will have to go to our pipeline and I mean just mess with the code, and it will be a disaster when the pipeline fails. Okay, so in this what we'll have to do, if we get a requirement that so and so is the data change or the mapping file, we just need to copy this configuration, add a comma, make the change. That's it, nothing else. Okay, so I'll just revert back because it is already working fine for me. So yeah, this will generate the SQL joins for me. Okay, Ginger SQL template. So this is the configuration file, and we are using that in the, see, I told you, one big table SQL template wherein we select the staging columns, all the columns, and we loop through it. So Ginger template uses this different format of coding wherein for loops we use braces and percentage, and we use this code line for tabling mappings and percentage include. This is for loops, and for variables we use double braces with a space and the variable for printing of the thing. Okay, so this is nothing but the code, and finally we have the gold layer. Okay, so this is where we are actually creating the what we say, the dimensions and fact tables, and we are performing the slowly changing dimension type too. Okay, so in this we are using Spark declarative pipelines and delta tables. Okay, so this is it about the code. I'll quickly go ahead and run the pipelines and let's see what happens. Okay, so we are inside our pipeline, and what I'll do is I'll quickly do a full refresh run over here, because see, I was already testing out the project, and right now the project was successful, as you can see over here. What happened is Databricks stores a cache memory, okay, wherein it stores the schema and all the checkpoint location and everything. So I don't want to run the entire workflow or job right now. I have to do a full refresh. With full refresh, what will happen is it will basically give me a clean state, okay, wherein there is no lingering cache of schema or anything, and the pipelines won't fail. So I'll quickly go ahead and start a full refresh. I'm doing it from scratch just for demonstration. Okay, so let me just quickly do this, and at the end we'll query the tables and see how the pipeline works. So this will take some time, a couple of minutes, around 10 to 15 minutes, because since I'm using a trial resource in Azure, I am limited to mm, I'm limited to very mid to low end resources in my what do we say, the architecture, Spark clusters, because if I exceed the reset, the limit that has been already set by Databricks and Azure for free resources, my pipeline will crash then and there only. Okay, so I'm using low end resources, worker nodes and everything right now. So this will take around 10 to 15 minutes. So let me be right back once the pipeline has run successfully. Right now it's 12:30. Let's see when it's. Yeah, so the pipeline has initialized, and it has received all the resources. So this is what is happening. It is creating a fresh schema and everything. I mean, it has truncated all the lingering data and the schema and cache and everything, and creating everything from scratch, and running the pipeline. So let me quickly zoom into this. Okay, so what it has done is it has run it has pulled the bulk writes table. Okay, bulk writes, and ingested the live stream that I was talking about earlier. Where is it? This. It has successfully pulled the data from events hub as well as the Azure Data Lake, like 28 entries. So yeah, so it has created the streaming staging table as well. Yeah. So let me just quickly zoom in. So what it is doing is it has created uh, it has ingested the streaming data, and we already have the bulk data from our data lake. Okay, then it has created the staging table, and further in the silver layer it has created the OBT rights table, which is nothing but a materialized view. Okay, so this was basically done by the Genia templates that I was showing you earlier. Where is it? Oh, hold on, recents. Yeah. So yeah, the one big table is created by this. That's basically what it has done is it has merged all our raw data, the bulk writes and the mapping files, as well as the live stream data that we are getting from the pulling from the event hub. Okay, and further it has created all the views in the gold layer that I was talking about. It has created all the dimension views and fact tables. See, one option to let me just. UI isn't very friendly with Databricks. Seriously. Yeah. So this is the final pipeline it has completed. It has created, see, all the dimensions that I was talking about. We had all the mapping files over here, raw mapping files, like cancellation reasons, cities, payment methods, write status, and all. So what we did is we created separate dimensions. I mean, basically star schema. Okay, so what we're doing is we are creating one big table as well as star schema. So this is for what do we say, serving the data to our analytics and BI teams. Okay, so that's why I've created this dimension, booking, driver, location, and so I'll go ahead and quickly query. First, what I'll do is I'll query and show you the what do you say, the streaming data I was talking about earlier. We saw 83 uh, yeah, 83 records. Yeah, 83 records. Now we should have more than 83. Let's see. See, I told you earlier it was 83. Now we have around 100. Yeah. So these were basically generated at fresh new records. 100th one is, see, I can compare it as well. Ride ID is 1BC51C and the last part is CACDA. In the event hubs as well, it should be, see, 1BC151C and CACDA. Okay, what is it? Yeah. So see, this is an very uncleaned, unformatted JSON string. Okay, so the final query, I'll quickly show you. Okay, so this data is cleaned and structured via this inside the silver layer. So hold on. Silver. I see the schema that we created earlier. This was basically to structure that JSON string that we are looking at. Okay, and what we do is we pass that data. So we pull that data. Okay, and we read that data using spark.readString.table from the bronze overrides. That is where the data is being pushed, okay, stored, and then we pass that data by using stream data frame dot with column. We create a new column, past writes, and we use this to basically structure that data from JSON column writes. Okay, so the data from the staging rights. So yeah, as I was saying, we transform this string JSON file in a silver layer using this from JSON column writes this code snippet, pass data frame is equal to stream data frame dot with column pass. So we use from JSON call to properly structure that data. Okay, the writes data that we are live stream data that we are getting from the event hub. Okay, and we select the pass writes. So I'll just I know it's confusing, I will clearly show you. So this is the merged data, I mean the bulk writes and all our live stream data has been merged and properly structured. So if I want to show you exactly what has happened, what this silver transformation has done is, so let me just quickly go over here and let's say, yeah, we remember this 100th entry, okay, in the Uber topics. See the same ID. What I'll do is I'll quickly query the staging table wherein the data has been merged with the bulk writes and the live stream table. Okay, I'll copy this ID and I'll query this staging table where ride equal to this ID. Okay, the 100th entry that we did, I mean the booking that we have done in the event hub. So let me see. Installation reason, where is this ride ID? Just query the table, so obviously we have the ride ID somewhere. See the same ID over here. Confirmation number is IV46, passenger ID is B6, and confirmation number, see, so same ID, we have the data in a very structured and proper format, just like this schema that we have defined earlier using the bulk write table. Okay, so where is the project confirmation number? Let us match that as well. See, IV4 619 MP88 619 MP88. So this string was transformed and properly structured and ingested into our staging table. Okay, the staging rights table that we've created. Now, yeah, so this is the Unity catalog that I've created. Okay, and here over here all our data, all the gold layer and silver layer transformation and Spark declarative pipelines and everything. So the end result is all these tables. Okay, so we have total 17 tables that were created by the end-to-end pipeline that we just ran. Okay, so bronze over, this is the initial stream, okay, that we are ingesting the, what do we say, the unstructured JSON string events that we fetched from our Uber topic. Okay, and this is the bulk writes. This was ingested from our GitHub, okay, via the ADF pipeline into the we pulled the data from GitHub to Azure Data Lake via ADF pipeline, and from Azure Data Lake we pulled it into our Databricks. Okay, so this is the catalog wherein all the data has been pulled. So this tables that you see, dim booking, which is nothing but dimension booking, dimension driver and everything, and this final fact writes with contains all our factual data. We are quickly going to query all these tables and see how exactly the data looks. Okay, so these were created by our gold layer. Okay, the final Spark declarative gold layer code. Okay, and this is the one big table, the OBT writes, that have been generated by the Jinja templating that we are talking about. Okay, and staging rights, these were all created in a structured end-to-end manner, okay, by the pipeline itself. I did nothing, I just created the pipeline and linked all the code files and all the notebooks in a structured manner and just ran the pipeline. Obviously I did all the troubleshooting and everything already, so this is a fully functional pipeline that I've built. So let me just quickly go and test out all the queries. So I've already written out these queries so that this video doesn't get too long. Okay, so we have OBT writes. So let me just quickly, where is it? OBT writes, the one big table, materialized view that has been created by the pipeline, the Jinja template and all the silver layer transformations. So this is how the data looks. This is basically the merging of all the mapping files, all the bulk writes data, as well as this Azure, the event hubs data that was being generated by this web app that we created. Okay, so all these three tables have been merged together, okay, and created this one big table. As you can see, this entire table with all the columns and mappings and everything. Okay, so initially what we had is, we had only this, where is it, yeah, before the merge and everything. Say, let's say we have this bulk writes data, so we had all the mappings in the form of numbers. You can see, let me just quickly show you where is city ID and everything. See, pickup city ID is 6 and city means all the city IDs are in numbers, and all the other data like ride status ID, okay, and tip amount, total fare, vehicle color, we have vehicle ID. See, vehicle make ID is in numbers. We didn't actually have the complete data. Okay, this is the historical data that we had, the bulk writes, and after merging it with the mapping tables into the one big table, this is what we get. Where is that? Sorry. So after merging it, as I said, ride ID was like pickup city ride ID. Pickup city ride ID was 1, 2, 3, and on that. See, vehicle make ID and everything. So after merging, after the one big table, it is, quickly find out, yeah, pickup city ID 639, and we have the names mapped, the city names mapped to it. Just hold on. Yeah, so earlier in the historical data, as you can see, we did not have any city name, okay, but over here after merging we have all of that. For city ID we just had ID, but here after the mapping we have the city name as well. See, cup city name, so 6 is for Philadelphia. Chicago is for the pickup ID for Chicago is 3. So let us say I just want to filter out the cities, the city ID 3. Okay. See, everywhere you'll see Chicago over here. Where is it? See, Chicago, and we also have pickup state, which is nothing but Illinois, and pickup region, which is Midwest. Updated add drop off city. Okay, so all the IDs and numbers have now been properly merged and joined with our the bulk rights and all the data in the bulk rights in the live stream that we have generated. Okay, it had all the IDs, drop off city ID, pickup city ID, vehicle ID, and everything has been successfully merged and mapped using the mapping tables. Okay, via the one big table that we have generated. So now quickly querying all the what we say the dimensions and facts that we have generated. So let's say we select everything from our Uber, which is nothing but the catalog name bronze dot fact rights. So let's see what we get. Okay, so see all the data, all the factual data, all the numbers have been pulled. I have entered all the IDs as well in the facts table. Okay, so driver ID, passenger ID, all the IDs and all the numerical data. Let's say the duration, minutes, distance, miles, and surge multiplier, total fare, subtotal, everything has been merged into facts table. Okay, next we have dimension booking table. All the bookings details must be there, should be there. Okay, ride ID. Okay, as per ride ID we have the booking confirmation number, ride status ID, ride status as well. See, for 1 it is completed, for 2 it is cancelled. So it has been mapped successfully with our mapping tables as well. Cancellation reason ID is 4, 1, 2, and the reasons, some are mapped, some are not. I mean, yeah, obviously it depends on the passengers. Okay, so this is how basically our data has been structured, and these are all the booking timestamp, pickup timestamp, drop off timestamp. Okay, now next we have our dimension driver tables. Same thing, all the driver details have been mapped into this driver dimension. Okay, so this basically helps in the analysis that our BI team or analytics team will be doing later on after we serve this data to them. Okay, so these facts and dimensions help them with the analysis and all. We have dimension location. So this is where we have performed our slowly changing dimension type 2. Okay, so let me just quickly go into that code. Where is it? Yeah, so this is my location dimension table, wherein see this is the final code layer declarative pipeline code, wherein in the dim location we have used, see, slowly changing dimensions type 2. Okay, what we did is we created the delta live tables view with the name dim location view. Okay, and we defined the location view, dim location view, and which this function, this definition returns the streaming. And these were the troubleshootings that I performed, so kindly ignore this. So basically it what it does is it reads the data from the live OBT writes, the one big table writes to table that we have created, right? And it reads the location data, the mapped location data from there, and we basically call out the pickup city ID, pickup city name, everything related to the location. Okay, so that we get over here. So what I'll do is I'll quickly query the remaining tables as well, and then what we'll do is we will try to change the data within our GitHub repo. Okay, so that we can actually demonstrate how the slowly changing dimension works. Okay, so let me just quickly also all the passenger details over here. We have the payment dimension and the vehicle dimension as well, which contains all the vehicle details. Okay, all the, yeah. So all these mapping, I mean, sorry, the dimension tables and facts were pulled and created from the one big table that we have already generated in the silver layer. Okay, so yeah, basic QA testing that I'll do. So what I'm doing, I'm selecting from these two tables. Okay, so we are just counting. So this isn't very big data, this is for demonstration. I have just created. Okay, these were as a demonstration project. Okay, so the functioning will be same even with a very huge data. So currently we have 2100 records in fact count, I mean the fact table and the one big table as well. Okay, then let's say I select city ID, pick up city name and updated and everything, start at and end at. So this is where I can show exactly how the slowly changing dimension works. Okay, so this start at and end at is I will first run the entire workflow. Okay, and okay, so let's do it like this. Instead of being so confused, what I'll do is I'll quickly go ahead and make changes to my mapping cities. Okay, so since this is the location dimension that we are working with, so here what I'll do is I quickly add something. Okay, let's say new New York or new Los Angeles or something like that, and as well as you can see, the time stamp updated at is 11:13 8th April. Okay, UTC. What I'll do is I'll update this as well. I'll just quickly fetch the current timestamp and edit this entire mapping table. Everywhere I'll add something like new or ABC or anything. So I'll just simply enter new before all the cities. Then what we do is we quickly do a full ADF pipeline ingestion. Okay, we ingest it into our Azure Data Lake. Then we go to our Databricks workspace and pull the data from here, the updated mapping city, these map files and everything into our Databricks. And what we do is also we'll make some more bookings. Okay, so since we have already 2100 rides, we'll make a couple more as we go ahead, and let's see how it works. Okay, so where were we? Yeah, so the start at currently so basically what this is, it tells us the yeah, so the start at tells us the current, I mean it tells us that, see, city ID 1 is New York and this is the current stamp. Okay, as soon as we make a change to it like ABC New York or something like that, what will happen is we will see a timestamp over here in end at. Okay, so that basically shows that the data has been changed, the column has been changed, and you will see null over here. So that's what is supposed to happen with a slowly changing dimension. Okay, type 2. So that's how it works. So right now all the city IDs and their particular city names have this start at timestamp. Okay, as soon as I make the changes in the mapping file for cities and rerun the entire pipeline and we come to this point, we will see something different. Okay, and let's say, yeah, also we can verify if there are any missing passenger details, because we do not want any rides to be booked with 0 passengers, right? It's not possible. So yeah, basically missing passengers is 0, correct. And yeah, so what I'll do is quickly go ahead and fetch the timestamp. This is the current timestamp, okay, from UTC. So let me just quickly go and make the changes in my GitHub. Okay, so I'm in my GitHub repo with the map cities mapping file. What I'll do is I'll quickly go ahead and add the new timestamp. Okay, where is it? Just fetched it, right? Yeah, yes. Okay, copy it and it over. Initially it was 8th of April 11:13 something. Now it is 19:30, basically 5:30 p.m. okay, as per UTC. So it has changed. What I'll do is I'll quickly go ahead and copy and paste it everywhere, timestamp, as well as I'll add new over here. New Houston, New Chicago, New Phoenix, and San Diego, New Dallas, New San Jose. Okay, and which one? Yeah, you quickly go ahead and copy paste everywhere the latest timestamp. Earlier it was, see, 11:13. Now it's 5:38. Yeah, so made the changes in the new, yeah, New York, new Los Angeles, and everyone new I have just added for testing. And you can add anything. Okay, I'm just doing it for simplicity over here. And the updated timestamp. Okay, now simply commit changes, commit. This has basically, so for references, just for your reference, right now see, I'll quickly show you. It was updated at 11:36 p.m. Okay, on 8th of April. Edit. See, new city is New York. ID 1. Timestamp you can see 8th April 2026, 11:13 a.m. I believe, as per UTC. Everywhere you can see. Okay. Now what I'll do is I'll quickly rerun the ADF pipeline. Okay. The last run was, we can also monitor and see the pipeline runs over here. So the last pipeline run was 11:36 p.m. It was successful. Entire thing was successful. Okay. So I'll go into pipeline again and rerun the entire workflow. Sorry, the pipeline. So it has started. Okay. So this is nothing but the lookup file that I created, files array that basically demonstrates the, what do you say, the data lake structure. Okay, this link services, data lake link services, GitHub, these are both used. See, the link hub, the GitHub link service is used to connect to ADF to GitHub, okay, and get the data, and the link service data lake is used to ingest the data into the Azure Data Lake. Very simple but powerful pipeline we have built over here. Then we have looped through, since we have multiple files over here, right? Mapping files, bulk writes data and everything. So what we are doing is we are looping through. We are not adding more and more code snippets. Okay, a lot of code to, single code snippets to pull the data. We are looping through it, and what we are doing is inside this, for each activity we have copy activity, which basically pulls the data. HTTP, we are using HTTP dataset over here to pull the data from GitHub. Okay, so source is the data source where the data is residing is basically GitHub, and sink is nothing but the destination where the data is supposed to be ingested. So ds ingest is for this. If I show you the path, you can clearly see ingest, and I have built a parameterized pipeline. Okay, wherein see the raw folder inside our Azure Data Lake. Okay, never mind. So the pipeline run is successful. See, it just ran 9th of April, 1:17 a.m. it is right now. I'm recording. Okay, so everything was successful. Now quickly go into Azure. Where is that data lake? I'll refresh. Show you properly. Go into our resource group, data lake over projects interface, data lake container. Inside this raw container, we have ingestion folder. See, it has been updated to 9th of April, 1:17 a.m. Okay. And my most important mapping file that we are using for changes. See, you can see New York and the latest timestamp that we just pulled, which is as per UTC, it is 8th of April 1938. It is 5:38 p.m. I believe. New Chicago, everywhere new, and the latest timestamp. What we'll do is we'll quickly go. This time we're not doing any manual runs or anything. Okay, we will simply run the entire workflow that we have created. Okay, what I'm doing is I'll go into my jobs and pipelines. So I did a lot of troubleshooting and everything. So this was the writes ingest pipeline that we are we were doing initially with a full refresh. Okay, so we were basically doing a clean slate run wherein we did not have any lingering schema cache or anything into the Databricks, so that we do not end up with any errors or crashes. So it has been going great up until now. Now let's run the entire workflow over end-to-end orchestration workflow that we have built. And what I did is I have added this trigger as well. So what it does is every 2 hours this trigger runs and it looks for any new data that has been generated, okay, via the live stream. Or let's say just now we made changes in the mapping file for cities, so that way we can demonstrate the slowly changing dimension as well. So what I'll do is I'll quickly go ahead and make some more rides bookings. Earlier it were 2100 records, now it should be more than that. Okay, so let me just quickly get back to you after making some more booking rides. Okay, so I've made a good number of ride bookings right now. Okay, what I'll do is, so since we want to show it to you right now, demonstrate it right now, so we'll not wait for every 2 hours for this trigger to run. Also, I have set up alerts as well that I get on my email, okay, via my email, that the pipeline has run successfully or failed, or etc, etc. Okay, where's my, yeah, so we should see these are previous testings that I was doing. So yeah, your Azure Databricks job has finished and it ran successfully. So failure or whatever happens when the pipeline starts and ends as well, so I'll get notifications. So this helps me to, stay alert. Okay, we do not miss on important data and or any face any such problems. Okay, what I'll do is quickly go ahead and run. See, triggered run performance optimized mode. Okay, so this is where the magic happens. Okay, so this ingest mapping data, what it will do is it will first pull the data from, it will pull the data from our data lake from here, all the historical data and mapping files, as well as it will run that bronze ADLS that we did, that the notebook that we had. Okay, this one, it will, what it will do is will pull everything. Where is it? Okay, yeah, from the bulk rights as well as the live stream that we have generated over topics. Okay, we should see some more rides over here since I made a good number of bookings right now. Fresh, see, more than 120, 130 we have, almost 150 records. So it will pull that and it will go ahead and do the transformations. Yeah, so it will pull all this events, live events, and yeah, rest you are already aware of the pipeline. It will just merge and run everything. See, as I was explaining, and since the machines, the nodes and worker nodes and executors were already up and running, they were hot. Okay, they were in functional mode, so it ran successfully without any errors. Finally, what I'll do is I'll quickly go into these, show you the, yeah, so it ran this initial load from the Azure Data Lake into the Databricks code. Okay, and some tests over here, and is it the pipeline? Also, as I was telling you, I have set up alerts, so I did receive all the alerts as well. See, the latest one, 1:24 a.m. Okay, I received the alert that your Azure Databricks job run has started, and workspace ID, I got the ID job name, which is nothing but Uber end-to-end orchestration job run, task run. Okay, DLT and everything. So it ran successfully as well. Okay, within 5 minutes, since the resources were already active, it just needed to initialize and run the pipeline entirely, the workflow itself. So the status was success. 4 minutes. Yeah, you see time duration, you can see started. Okay, this the next run has started, since I guess because of the schedule trigger, the schedule that had been set up. I'll quickly, okay, let's wait for this to happen. Let's see what happens. It's doing it again. Of course it will fail. I mean, these were failures. Sorry, it did not fail right now. My bad. So many failures. Failures in troubleshooting. Took me weeks to finish this project, but then yeah, I did successfully because I faced these errors. The reason was me itself. It was me only. I made certain changes to code. I tried new things, and that simply landed up to errors. Nothing more. So the second run has, see, as I told you, I have set up this schedule. So the schedule time was up. It was okay. Let's wait for this to happen. So we just received another email stating something. Okay, it failed. Why did it fail? Let me see. Even Azure Databricks. Okay. It should not fail. Yeah, okay. So this error is nothing to be worried about. It just happened. Okay, we can just simply repair task and it will run successfully. So what will happen is, since I told you earlier, right, due to the Azure free trial that I'm using, I'm limited to resources, right? I cannot use very high-end resources. Means I'm simply using 4 cores something. Yeah, 4 cores and 8 GB of RAM right now. So because they cost less, right? And it's a trial. I cannot exceed that. If I exceed total number of 8 cores, okay, the compute will fail. It will just throw me an error that you have exceeded the quota and everything. So that's why I received that. Simply, since I'm already doing it, I'll show you as well what I'm trying to say. Just rerun it, because what happened is we simply exceeded the resources. That's why we received that error. Okay, it took more than the initial time it was supposed to take to run everything, the graph and everything. Okay, that's why we got it. We just reran it live. Okay, I haven't paused anything or doing anything. See, it's running. Let's see what happens. We received another notification. Yeah, of course, the pipeline is running now. Okay, let's wait. Let's see what happens. Yeah, so the rerun was successful, kind of. Okay, so this is where it is happening. It has created when it's creating all these views, wherein using those views it will create those streaming dimension tables and fact tables that I was talking about, as well as the final one big table, the staging rights and everything. So this is how the actual pipeline run looks. Okay, it's a good thing that the scheduled run happened as well. As I was recording, I could actually show you how the schedules run as well. We can do different types of schedule. I did a 2-hour schedule. Okay, we can set it to run in a smaller time span, as well as within days or weeks, whatever the company requirement is. Okay, I'll try to zoom in and show you the graph that is happening over here. So this is the DAG that has been generated. So it successfully created the streaming table, bronze Uber right streaming table, the initial table, then the staging rights, wherein it loads the data into the silver layer and does all the transformation, and finally the merging and mapping, merging of all the mapping files, the raw data, the bulk data, raw data, and the live streaming data that has been pulled from the Azure Event Hub. Okay, yeah, so it merging happens and the one big table is created using the Jinja templates that we already discussed. And finally, yeah, the run is successful. Finally, I did a lot of troubleshooting and a lot of repair runs to this workflow, because that's what it basically is, right? Trial and error. Data engineering is basically solving those pipeline crashes. Looking into those pipeline failures, troubleshooting it, making code changes, and rerun. That's how a pipeline, robust, bulletproof, we can say, pipeline is built that doesn't fail. obviously it failed right in front of you right now because I'm limited to those low-end resources. See, I received the mail as well for success. Perfect. See, earlier I got this mail for failure. Now after rerun, it's success. So these are very helpful. I mean, let's say the pipeline for some reason fails in a non-functional hour of the day, right? Let's say at night around 3 a.m., 4 a.m. the pipeline fails. So I could get these emails and I can stay alert and I can quickly log into my workspace and see what exactly happened, and we can repair those tasks and get the flow running. So we don't actually have to sit overnight and stay alert that when this will fail, when this will be successful. This way it happens. Okay, it observed 20 records. These are basically the records that we just generated over 150, over 30 bookings I made as I was trying this rides booking. Okay, this is the successful final DAC, and you can see all the tables were generated. See, absurds, expectations. Obviously, we did not set any expectations to drop any records as of now. We can do a lot of things going ahead. Okay, so this is, see, success. All the tables have been created. Now let us go and try that. Is it the slowly changing dimension thing? Also, we can quickly see the count as well. Initially it was 2100. Now it should be okay. What happened? So let me finish. People should have more than 2100, right? Why is it? Table. Did the records expire? 204 records. Total 12125. Okay. Right. Actual data 100. Okay, yeah. Oh, the final merge and everything. Okay, so here we can let me just clear this filter. Yeah, we can see. Yeah, so as you can see, the earlier the one big table had 2100 records, but now it has more 25 records. These 25 records are the latest one that we just pulled from the stream over here, the event hub stream. Okay, if you want, I can quickly do a recheck wherein the ride ID is 8. Yeah, ride ID is this. I'll quickly filter the data instead of writing a query over here, just to show you that the latest, this was the last and latest entry over here, the 153rd entry. Okay, so where's this? Quickly go into ride ID column and yeah, over here. So I'll do a quick filter. This and ID is one off or equal to basically this. So yeah, see, it has this exact ID 8D80F, pickup, longitude, latitude, cancellation, reason, and everything, and also it has all the mapping data mapped to it. Okay, the city, the vehicle make ID, vehicle color, and everything, etc. So yeah, exactly this new record. So it is functional. Okay, in real time, if we let's say this was an actual application, let's say for this was the real functional Uber application, and this is how the rides were booked. Okay, the what we say, the passengers booked rides and everything. So this is how the events are generated and captured via the Azure Event Hub, since we are using the Azure stack entirely for this data engineering project. Okay, so this is how it is recorded, and yeah, so this is how the one big table function and the entire end-to-end pipeline works. Okay, so now our biggest what do you say, so most important part in our project, the final part, is the slowly changing dimension type 2 demonstration. Okay, so yeah, perfect. See, you can see, right? Earlier what I told you, like it was New York, Los Angeles, Chicago, and everything. See, the ID is as it is. ID won't change. What we did is we changed the dimension over here. So this is exactly what I was trying to explain earlier. This is how slowly changing dimensions work. Okay, the type 2 dimension basically that we have implemented over here. So yeah, as you can see, the timestamp we added was UTC 1938, which is I think um, 5:38, I believe. Correct me if I'm wrong. If I'm wrong, okay. New York and everything. So exactly. So once that was done, the pipeline ran successfully. It did all the changes. It did all the code work over here. Yeah, I'm still here. Okay. Hello. It did all the transformations, ingestion, and everything. One big table, and finally, it did the schema part as well. The Ginger template is working flawlessly right now, and this is a template that I built. I mean, I did a little bit of research and documentations, went through documentation and tried to build it on my own. Okay, so this is working perfectly. This entire template thing. I won't be going to very detailed right now, or the video will be very long. Okay, so and yeah, after the update, after the slowly changing, see, as I was saying, start at end at, see, end at is null. So why this is null? So initially it showed null everywhere, right? So the null was basically stating that there were no change. Okay, there were no change at all. It started at so and so timestamp and it continued. Okay, but now the latest timestamp, see, earlier it was 8th of April 11:13 a.m. I believe, and after updating it to the current timestamp, which is nothing but 5:38 p.m. 8th of April. So see, and as soon as, see, New York, new New York, okay, New York is showing null because this is the current update. Okay, this is basically the historical record that we are trying to keep. So SCD is basically used to keep the historical record of all these changes. Okay, let's say tomorrow I want to know what exactly changed in our static data set, okay, in a raw data, I mean the mapping files. So this is how we keep a record of it. So this is all in all slowly changing dimension type 2. So everywhere you can see, let's say New Dallas, you can see record number 17, pickup city ID 9 Dallas, pickup region South, pickup state Texas. Earlier the timestamp was start at this, later it has been turned to this, and this exact 5:38 p.m. UTC timestamp is reflected over here as well. And now the end at is null. Why? Because this is the current thing. Okay, the current timestamp for the change. Now it will be like this only. But let's say I again go into this and change this timestamp and add something new. Let's say New Ultra New York, New Ultra Los Angeles, something like that. This is naming convention I'm using for demonstration. Okay, nothing like that. So we again will get that new timestamp over here. Old one, this one will stay up. This will go up, and we'll get that new timestamp and the new Ultra city ID. You're getting it right. Whatever the name we suggest or input will be over here. So this is how slowly changing dimension works, and this is the basically the record of historical record of what changes has happened over time. Okay, because obviously city names do change, right? Not today, within let's say years or decades, it do change. People do these things. Okay, so that was about temp location. Now what we need to do is, so now the thing that remains is basically serving this data. Okay, so the gold layer and everything is done. Okay, I've shown you all the queries, all the dimension tables, and yeah, this data set can go as long as it wants. I mean, I can generate a quick script just for booking rights, live rights. Like I can generate a Python script and make it just click on this book right, go back, book right. It can basically generate millions and millions of rights booking. Okay, for testing it can handle that, and all those records will be successfully fetched. I mean the pub sub model, the publisher subscriber model will successfully work. All the records will be fetched over here. See, 2 more records were fetched. Okay, so now it should be 155, correct? 153 earlier, 2 more records. So yeah, all will be fetched successfully. Then the scheduled pipeline will run successfully, and all the changes will happen successfully. No errors at all. Even if I get any errors, I'll get notified, right? Via this alerts that I have set up. I can quickly go into that, look into the flow where it failed. Am I running out of resources or not? And I can troubleshoot and rerun the pipeline to get the end result. Okay, so this is done. Now finally it's time to serve the data, and I think they have shifted Partner Connect to Marketplace. Yeah, because I cannot see it over here, it was here only. And let's search Partner Connect. Sorry, Partner. Is it? Yeah. Okay, here it is, Partner Connect integrations. And what we need to do is we have to go into Power BI. Okay, here it will ask us to use our server. Compute warehouse. We will select this only because we were using this since we are limited on the resources in the trial. Trial resources, trial period. I cannot use my actual compute that I have generated. Okay, so I'll simply select it by default. Click on download connection file. Perfect, downloaded. Now what this does is this basically opens Power BI and it asks for credentials and stuff, and we can quickly connect to our live warehouse over here and do the analysis. Okay, the visualizations and the SQL queries and everything. So this is how an end-to-end. So yeah, this is how an end-to-end pipeline functions in real time. Okay, in real world scenarios, we do the entire successful run. The pipeline run should be successful, end-to-end pipeline, and we serve the data to our downstream departments. Okay, to our BI departments, analytics department, etc. So yeah, basically all in all what I did is I built a Databricks job, the workflow, the complete workflow, which is nothing but this one over end-to-end orchestration that creates a strict dependency chain. Okay, it runs in a sequence, right? It first triggers a notebook to upsert any new batch metadata into the bronze data tables, and only upon success it triggers the DLT stream to process the writes. Okay, this prevents the pipeline from streaming out of date business loop. Okay, and in this the hardest part was basically tracking historical changes, as I showed you, the slowly changing dimension type 2 part. It was full of errors and failures and troubleshooting, seriously. So as I told you, it was the hardest requirement to track the historical changes in our business locations without breaking the live stream. Okay, to prove this works, I pushed an update to our source in the mapping files in the GitHub repo, as I showed you earlier. Okay, and when the job ran, the pipeline caught the override, as you can see in the SQL query over here, dim location, this start at, end at, and Databricks automatically applied slowly changing dimension type to logic over here. It safely expired the old records with the timestamp over here in the end at. Okay, and activated the new city names seamlessly, which is nothing like this. Let's say you look at Los Angeles. Okay, city ID type it. So yeah, it gave the end at, and it's seamlessly started. Applied the new name, city name, with a newer timestamp, and yeah, finally we serve it to the analytics and BI department via the Partner Connect. Okay, so this was it about the project. About the final, here we can pull this data and do a lot of further analysis, aggregations, and visualizations and everything. Already the video has gotten very long, so this was the end-to-end workflow that I have built. Okay, so yeah, and that brings us to the end. If you're stuck with me throughout this entire hours long build, thank you so much for watching. Okay, thank you so much for your time, and I'll be first to admit that I am pretty raw in this video making department, and this is actually my very first video demonstration. Okay, so I appreciate you be bearing with me throughout the entire live demonstration. I may have fumbled and mispronounced many things. Kindly ignore that. Okay, so the purpose. Okay, so my main goal here wasn't to make a perfectly edited video, but to truly demonstrate how an end-to-end data pipeline functions in a real world scenario. Okay, I wanted to take things beyond the basic tutorials and showcase my hands-on architectural understanding, from setting up the infrastructure to handling complex real-time data flow and slowly changing dimension type to logic overlay. Okay, so yeah, the ultimate reason I built this project and put this video together is that I'm currently open to new opportunities in the data domain. Okay, so I'm actively looking for roles as a data engineer, junior data engineer, analytics engineer, or a data analyst. Okay, so I'm incredibly eager to continue growing and learning in this domain, okay, in the data space, and I want to bring my skills to a team where I can contribute to building a robust data solution. Okay, so finally, yeah, if your team is hiring or if you might be open to providing a referral, I would genuinely appreciate your support. And please feel free to reach out and connect with me on LinkedIn. I'm always excited to network and talk about data architecture or even collaborate on a open source project like this in the future. Okay, thank you for watching, and I hope to connect with you soon. Bye bye, take care.